We will continue with the topic on operation on discrete time signals. Last class we saw about time shifting. Now today we will see time reversal. Time reversal otherwise called as folding. So here we are going to find x1 of minus n, x1 of minus n plus 2 and x1 of minus n minus 2. So problem, given x1 of n, the examination, the question paper, they will give x1 of n. Already we saw that 2, minus 3, 1, 2.5, minus 4 and 5. We are asked to find x1 of minus n and x1 of minus n plus 2 and x1 of minus n minus 2. So how to do it? First, as usual, we'll assume x1 of minus n as y3 of n. You know x1 of n ranges from n equal to minus 2 to plus 3. Therefore, here y3 of n will be, since it is x1 of minus n, it is reversal, n is negative. If this is minus 2 to 3, this will be from minus 3 to 2. As simple as that. So when n equal to minus 3, the y3 of minus 3 is equal to x1 of minus 3, x1 of 3. What is x1 of 3? From the given question, x1 of 3 is nothing but 5. x1 of 3 is nothing but 5. Similarly, y3 of 2, if you find out, it will be 2. So x1 of minus n is nothing but, we have to write the reverse of x1 of n. So this 5, it will come this side and this 2 will come this side. Yeah. Therefore, just write the reverse. Origin will be the same. So 5 minus 4, 2.5, 1 minus 3, 2. That is x1 of minus n. Next we will see x1 of minus n plus 2. How to do this? In 2 steps. First we do, even though it is time reversal, first we do time shifting. So if it is x1 of minus n plus 2, first find x1 of n plus 2. x1 of n plus 2 is nothing but the advanced signal of x1 of n. x1 of n. Advance means this arrow mark will go 2 samples this side because x1 of n plus 2. Okay. If you have any doubts, you can see the time shifting operation video. Okay. So x1 of n plus 2, arrow mark shifts to 2 samples this side. From 1, it shifts 2 samples to right side, minus 4. But the signal will go to the left hand side. Okay. So next, first, even though it's time reversal, first we should do time shifting, then the time reversal. Time reversal means of this. Okay, x1 of minus n plus 2. That means this will come this side and this will go that side. Just write the reverse of it and write the origin. There ends x1 of minus n plus 2. Next is x1 of minus n minus 2. Here also, first you do time shifting. x1 of n minus 2. Already we found out for time shifting x1 of n minus 2. We got the answer in the previous video. The same answer, write it here, x1 of n minus 2. Here I have put arrow mark. That's all. Now next is x1 of minus n minus 2. That's what we have to find. Write the reverse of this. So this will come that side, this will go this side. Okay, it is time reversal operation. For a discrete time basic signal, discrete time signal, we will take a unit step. U of minus n equal to 1 for n less than or equal to 0 and 0 for n greater than 0, because it is time reversal. U of minus n plus 1, the value is the same. Right? n. Since it is minus n, this will be less than or equal to, and this is greater. Solve this equal to 0, you will get the value of n equal to 1, put it here. That's it. U of minus n minus 1, value is 1, this is 0, this is n, this is n. Since it is negative, this will be less than or equal to, and this will be greater. Put the bracket equal to 0 to know where it starts and where it ends. If you put, we will get the value of n equal to minus 1, put here minus 1, here also minus 1. If you know the functional representation, we can draw the graphical representation. How to sketch it, already we saw that. So here ends time reversal. Next we will see the next operation, amplitude scaling, the third operation. Amplitude scaling, given x1 of n, we have to find 3x1 of n, and here given x2 of n, we have to find 0.5 x2 of n. So in x1 of n, this is the question. So here with x1 of n, we have to multiply each amplitude by 3. That's it. And for x2 of n, we have to multiply each amplitude by 0.5. Therefore 3 into 2, 6, 3 into minus 3 minus 9, Like that it goes, and we get the value for, we get the answer for 3x1 of n. And for 0.5 x2 of n, multiply by 0.5 this x2 of n. Okay, minus 2 into 0.5, 1. 3 into 0.5, 1.5, and so on. Let's write the answer. Which one? 0.5 into x2 of n. Okay, next is time scaling. Time scaling, we have to find x1 of 2n, and this is x2 of n by 2. Given x1 of n, given x2 of n, we have to find these two. What is the difference between amplitude scaling and time scaling? Amplitude scaling, you see the multiplication factor comes before the signal. Here it comes inside the time index. That's it. Okay, so as usual, we'll assume this as R1 of n or S1 of n is equal to x1 of 2n. You know, x1 of n ranges from minus 2 to 3. This is on the last video. So put 2n equal to minus 2 and n equal to minus 1, 2n equal to 3, n equal to 1.5. You know, discrete time signal does not have values at real numbers. It has only at integer values, at n equal to integer. Even though it is 1.5, it ranges from minus 1 to plus 1. So substitute the value from minus 1 to plus 1 here and get the samples. Okay, just substitute and see. Simple max, that's it. So S1 of n will be x1 of 2n. The value will be 2, 1, minus 4. This whole x1 of n, you see, it ranges from minus 2 to plus 3. This big signal has been reduced to just 3 samples. That means the signal is compressed, and this operation is called as decimation. Later in the last unit of DSP we can see. Okay, one of the applications of DSP. Next is we have to find x2 of n by 2. Similarly, put the value n by 2 is x2 of n ranges from minus 1 to 2. Therefore again put the values from minus 2 to 2 and get the values for s2 of n. Substitute and see. Substitute and see. When you put n equal to minus 2, this will be minus 2 by 2 is minus 1, x2 of minus 1, see the value and write it as minus 2. Then next is after minus 2, it is minus 1. When you put minus 1 by 2, you don't have values at real numbers, therefore this is 0. Similarly, at the till till s2 of 4, answer will be 1. So write the final answer, s2 of n, x2 of n by 2. So you can see a 0 is inserted between the samples and the signal is enlarged. Okay, and this is called as interpolation. This comes under the topic multi-rate signal processing. Clear? Okay. Here in decimation, or if the multiplication factor is inside, if it's the whole number, if it is 2n means one sample gets reduced between samples for x1 of n, and if it's n by 2, one sample gets added. Okay, this is about time scaling. Now the fifth operation is signal addition. What is signal addition? We have to add x1 of n plus x2 of n. Next is x1 of n minus x2 of n. Even though we call it as addition, here this x2 we are getting is negative sign. We are putting a negative sign and finding. So we have to find these two. So how to find? First is as usual, assume this as a1 of n equal to x1 plus x2. What is the idea here is x1 it ranges from minus 2 to 3. x2 is ranges from minus 1 to 2. I am talking about time index. Make it equal. Make the sample's length equal. Therefore here put one 0 here, because here you have 2 values, here you have 3 values, put another 0 here. The addition becomes simple. Okay, so this is a1 of it ranges from minus 2 to 3. So a1 of minus 2 is x1 of minus 2 plus x2 of minus 2. 2 plus 0, 2. Do that similarly. Last one is 5 plus 0 is 5. Just keep adding. Okay, and write the answer. Next one is minus 3 plus minus 2 is minus 5. Like that you proceed. Don't forget to put the arrow mark. Origin is important in every problem. Okay, next x2 of a2 of n is subtraction. Instead of addition we have to do subtraction. 2 minus 0, 2. Minus 3 minus of minus 2, which is minus 3 plus 2. Be careful, minus is a dangerous sign, as I told you before. My plus 1 sir told me in schooling, MCC, Chetpet, R. Lakshmi Narayan sir, wonderful sir. Minus 3 plus 2 is equal to minus 1, and This one 5 minus 0 is 5, and finally write the answer. Okay, be careful with the negative sign. Last one is signal multiplication. Instead of addition subtraction, we are doing multiplication. That is multiplication. 2 into 0, 0. Minus 3 into minus 2 plus 6. You know multiplication, and that write the answer. That's all. Thank you. Do well. We'll solve some university questions later.